Hello ladies and gentlemen, in this new video in which we will be talking more about Alusus language, we have mentioned or published several videos that introduces the language and explains how to build a web app from scratch with backend, front-end, and database. In those videos, we explained how to build the app, but we didn't dive deep into some of the aspects of Alusus language and some of the features that made this language unique and promising. In this video, I'm going to focus on explaining some of those features and explaining what deeply, a little bit more deeply, in some of the important features and distinctions between the language and other languages. In this video, I'm gonna focus on, or I'm gonna use the chat example, which we have talked about in a previous video, and we also have a whole article or a series of articles that explains how to do that step by step. So in this video, I'm not gonna explain anything about how to build the app and how this app works. I'm just gonna focus on some of the features of Alusus language. So this is the app. It starts with this login screen, and then you put your information, and then you submit, and you get into a chat screen, chat application. This is the code behind the app. The app is published on GitHub, and I'm gonna keep the link to that in the description of this video. But I'm gonna talk about a few things in this video. So first of all, I'm gonna explain a little bit some of the aspects of the syntax of Alusus language. In Alusus, the syntax focuses more on clarity rather than shortcuts or making like the code look smaller or the code look more familiar to or more comparable to other languages. We don't focus on that. We focus more on readability and clarity of the code base, and therefore there are a few things that we have kind of like made them as rules. So first thing is the difference between tilde symbol and the dot. So the tilde symbol, for example, you can say my var tilde ptr, and then you have my var dot memvar. So the dot represents, just like any other language, represents accessing a member of that class or of the class from which this object is defined, and the tilde denotes operator. And obviously we have the standard operators like the math operators, and then like the logical operators and or etc. And then we have the more programming specific operators, in which in Alusus it's all starting with the tilde operator, and the reason for this is because we want to keep clarity. And a good example is to compare this against the C language, for example. For example, in the C language, you might often see syntax like this: star, parentheses, another parentheses, and then end star, and then and my var. And this looks like a puzzle to a lot of people, or to anyone who hasn't seen the C language. This same thing, and I'll explain what this means, but in Alusus, this is written as this: my var ptr cast ptr integer content. So from looking at the syntax in Alusus, it's very clear what you're doing here. You're taking the pointer, then you're casting the pointer to a pointer of type integer, and then you're taking the content. Whereas in C, this is like, oh, what is this? Is this a puzzle? So obviously the C syntax is shorter, smaller, but again, we focus on clarity and readability rather than just making things short. So that's the first thing I wanted to mention. The other thing that's important to note here is the difference between the square brackets and the parentheses. In Alusus, every time you see a square bracket, this represents a compile time argument passing, whereas a parentheses is runtime argument passing. So And therefore, if you look at this code, for example, you'll see things like this definition, for example, db ref and then square bracket. This is basically a template argument, and the template argument, the processing or the handling of template arguments is done at compile time, obviously. So that's why we use square brackets here. Whereas things like let's look for rooms and then accessing an element is done with the regular parentheses, and that's because this is at runtime. So uh, some people might think, why are we using square brackets rather than angle brackets, for example? And the reason for that is because in Alusus, compile time arguments can be anything. It can be actually an entire code. So an example is this, where we're doing like a dot where in here we're passing a statement or a comparison or expression basically as an argument. So if you do something like greater than and then you use angle brackets as the brackets, this is completely very confusing. This is both adds complexity to the compiler itself, and it also makes things confusing to the reader, because like the one who sees this, what is this, like where of name, it looks like a template and the argument is name, whereas actually this whole thing is the argument. And like you can pass like an entire code in here, you can pass an entire function, you can pass a block of code. So using something that is used in the expression is not very clear, whereas in Alusus we just made it a global rule. Every angle, every square brackets is compile time, every parenthesis is runtime. And then you can also see that something that might be a little bit confusing to newcomers is the use of the parentheses for accessing array members. So this is an array, and you're accessing the members using the parentheses rather than square brackets, as you might expect compared to other languages, or as people coming from other languages would expect. And again, the reason is because accessing members of an array is a runtime operation. And if you think about it, really, what's the difference between an array and a function? And uh, an array, you can think of an array as a function whose input is the index and the output is the content of the array. And in fact, in here, I mean, this array is a class actually. It's defined as a class, and it defines the parentheses operator. So it actually is a function behind the scenes, even though it's an array. So it makes more sense to just use parentheses. The other thing I wanted to mention is the concept of handlers in Alusus, like you see here. And handlers are basically a syntactic sugar for defining a function that handles things that are not just a function, but it allows you to define like override operators and things like that. So you can do something like handler this equals integer, and then this function will be executed. So this function will be executed when you assign an integer to this variable. So if you do define, what's the name of this class? Text entry. So if you just define text entry and then you do var equals 5, then basically you're triggering, in this call you're triggering this function. You can, and this is like, it's used basically, it's used in a generic way. So even when you define a member function, you just say handler this dot my function, and that's how you're defining a member function. You can use it to define properties. So you can say handler this dot my prop equals integer, and then you can say handler this dot my prop integer, and this gets triggered when you access the property, and this gets triggered when you assign something to that property. And then here you can see we're using the handler again, but we're not applying the handler to this. Instead, we're applying to this type. So So now, by default, when you put in Alusus, when you put a class name and then put parentheses, you're actually instantiating a temporary variable of this. But in this case, we have overridden this operation in here. So now this will trigger this function call and will cause instead of a temporary variable, we'll be creating an object on the heap and return a shared variable to it. So it's a very neat way to generalize how you define functions, properties, operator overriding. All of that is done with just a single handler operation or handler syntax. The other thing I wanted to mention, which is probably already clear by now, is the at sign. So every time you see an at sign, that is what do you call it? A modifier or an attribute. And in Alusus, there are predefined attributes like this injection attribute. I'll get to that in a future video to define what injection is. And then there's also user-defined attributes like this one, and then like all these ones, these are user-defined attributes. So user-defined attribute will just attach data to the definition that can then be used by compile time execution. So that is in a nutshell some of the main differences in terms of the syntax. The other thing I wanted to highlight in this video is the ORM, and we've talked about this in the previous video. We have the rows library is the ORM used in Alusus, and it defines some of its own set of attributes. And in here, like when you assign these attributes to the class, it makes it a model, and then the library will automatically be able to generate the SQL for creating the table itself, and also for accessing the table, like reading and writing data to that table. So all of that is done by simply assigning those attributes to the class members. And then the other thing that is important to highlight here is this syntax. This is where we read data from the database. We say db.from, and then you give it the model, and then .where you give it the expression, and then .select, and then this basically gets converted into an SQL statement. And here you can see the highlight here is that the where clause is written as just an expression in Alusus based expression. So you can do things like and then you give it, for example, password equals, or you can do, for example, parentheses, and you can do or blah blah blah. So you can do a full expression. You give it in the same syntax as you do in the rest of the language, and the library takes care of converting that into proper SQL. So that's pretty neat. People who are coming from other languages might appreciate this nice touch here. But the more important thing to mention here is that the computation, or this conversion from Alusus syntax into SQL, happens at compile time, not at runtime. And that's an important distinction. So basically that means you get better performance, because all of that string manipulation operation is happening once at compile time, and then at runtime you're just basically doing a replacement of the actual values. And then here, the other thing to note here is that we have an object, we're calling dot from, like you're calling a member of that object, and then we're using the square brackets. And now, so this is basically, you're making a function call at compile time, almost. You can think about it of it this way. So, and the way this is happening is that this is actually defined as a member macro. Now, this might be confusing or new to maybe most people, because when most people know macros as a pre-process that happens in many languages, like the C language, for example. In Alusus, macros are different. They don't happen at compile time. They don't happen at the pre-process time. They happen actually at compile time. So they are aware of the syntax, and so we can have macros that are member of a class. We can have macros that are defined within a certain module and can only be accessed uh, by referencing the model first. Sorry, the module first. And then in this case, we're defining it as a member macro of the DB class. So any variable of type DB, you'll be able to access dot and you access the macro, and then this macro, the computation of this macro, obviously like any macro, will happen at compile time. And then at compile time, you can actually run full code. So basically, this allows you to decide when to do computation at compile time and when to do it at runtime for the best performance possible. Um, I think yeah, I think that's all I wanted to mention about the ORM. The other thing I wanted to mention is the backend versus front end. So in here you can see there are these functions that are marked with the BE endpoint, and then you'll also see in on the front end side you'll see this function that's marked with a UI endpoint. So these macros will allow the web platform library to know which code should be compiled into WebAssembly and which code should be compiled into just native, following the architecture of your machine. Uh, so so this basically is what allows us to put everything in a single file. So you can put backend and frontend in the same file. You don't have to worry about splitting your project into backend and frontend. Don't have to worry about any of that. You just put everything and you just mark which part you want to run on the front end. And then it takes care of compiling that. Everything is compiled, obviously. This is going to be WebAssembly, as I mentioned. There's no JavaScript involved. There's obviously some HTML because to have the page ready, you'll need to have some HTML container. So this will generate the HTML, generate the WebAssembly, make all the changes needed, all the preparation needed for having a server ready to serve that front end, that WebAssembly based front end. And then for the backend, it will handle all of like creating the backend, the server itself, and then injecting all these function calls into that backend at these specified paths or routes. So all of that is taken care of by the library for you. Um, and then the last thing I wanted to mention is this setup, the project setup code. These few lines of code will take care of basically managing the project completely. This will take care of creating the function that starts the server, creating the code that builds the or compile and build the final executable version that can be published. It also takes care of publishing directly uh, to Alusus net in this case, but you can use different publisher. So all of that is taken care of by this single call to the setup uh, member function or macro actually in this case, and then it will also take care of generating the command line arguments that are used to control the project. So let me just so if we do Alusus main without specifying anything, it will give us um, all the arguments necessary or possible. So you can start the application directly, you can build, you can publish, and you can also restore and backup DB. All of that is basically taken care of by this single call. And this would not have been possible if the language would not have been as flexible as Alusus, where like allowing you to generate code, allowing you to access your code and read your code and understand it. So for example, in this case, if you have asset routes, it will automatically look for those, find those asset routes, copy all those assets in the final folder that's going to be published. All of that's going to be done for you. And yeah, obviously you can't do that if you can't read the code and access the code itself. But in this case, in Alusus, you can at compile time you can run code that scans through. I mean, you can write any code, but you can, yeah, in this case it scans through the code base, looks for the functions that are going to be compiled into backend, the front end, the routes, picking all the assets, copying them, all that stuff is that will normally require an entire script, usually like a bash script in other languages, or a similar script. In this case, no, you don't need any of that. You just define it in your code, and that's it. So um, to someone who's new to the language and looking at all this, they might get the impression that you're dealing with a high level language. This is a pretty high level language. It's even higher level than JavaScript if you think about it. But in reality, this is actually a low level language. It's a very low level language. It's basically the same level as C. When we say low level, we're talking about C level, low level. And it actually is compatible with C. So you can actually directly import C libraries and use them. You just need to define you basically just need the header. You define the, the functions that exist in that library and use it directly. So so yeah, it is C level, and then we have all these we have this capability of extending the language. So we're extending it with libraries to allow it to give us some of these high level features, and we're doing that by carefully choosing what gets executed at runtime, what gets executed at compile time, and basically having the best of both worlds. Execution the speed of execution of low-level languages, security of low-level languages, plus the flexibility and uh, ease of reading and readability of a high-level language. So we're getting the best of both worlds. Now, and if you look at the code here, you can see that clearly. If you click on view the source, you can see the source here is really the HTML is just this part. That's it. There's no HTML. Everything else is handled by code, and this is the code. If we look at that, sorry, did I stop the server? I did stop the server. Yeah. So so there, obviously everything is compiled. The front end is completely compiled into. Why is it no name.watson? So this is your front end basically. It's a binary file. There's no there's no source code here. So this gives you better performance, obviously, because it's low level, and it also gives you better security because there's no compiler running during runtime. So when there's no compiler running, then obviously you can't do injections and you can't do a lot of the security holes that can be found in JavaScript based applications do not apply here at all, because you don't even have a compiler running. I mean, obviously the browser itself has a compiler, but we're not using any of that because we're just using it for for binding basically with the browser APIs. That's it. But everything else is just running completely compiled. So yeah. So with this, I'll end the video here. This was just a good short introduction. I will uh, I will do a comparison between between Alusus and JavaScript to compare the performance of both the backend and the front end. So stay tuned for that, and subscribe to the channel if you haven't subscribed already, so that you can receive that video, and also look forward for future other videos. Thanks again for watching, and have a good day.